More second-degree trig equations for us to solve. These follow the same procedure as in the previous examples, so I'm going to go through them both, but I won't dwell a whole lot on the details because most of them are not new, and I think you just need to see this happen a few times. You'll start to notice that the procedure is the same way every time. So, the first thing that happens when you have a second-degree equation is try to factor it. If you can break it up into first-degree equations, and then things go a lot faster. This one factors, it's a difference of squares. They've already made it equal to 0, which was nice of them, so we get 2 sine a plus 1 and 2 sine a minus 1. We solve each of those separately. So we get either 2 sine a plus 1 equals 0, which leads to sine a equals minus 1/2, or 2 sine a minus 1 equals 0, and that gives us sine a equals plus 1/2. So what angles are they talking about? I'm going to do all these on one set of axes just to save a little bit of space. If a can be positive or negative 1/2, that means we can be any of the 4 quadrants. We can be in the 2 quadrants where sine is positive, or we can be in one of the 2 quadrants where sine is negative. There we go. But either way, in this case, our opposite sides are 1, -1 if you're under the axis, and our hypotenuse hypotenuses are 2, and that makes this the 30-60 triangle. So we end up having 30 degrees. Now, for once I caught it a little early. They want a speaking radian here, so I mean our reference angles are pi by 6, and we get that reference angle in all 4 quadrants. Right, so as far as solutions, in the first quadrant, we really do get pi by 6. That one's easy. That's our standard angle. In this quadrant, we get pi minus pi by 6, which is 5 pi by 6. Bottom left, we get pi plus pi by 6, so 7 pi by 6. And in the bottom right quadrant, we get 2 pi minus pi by 6, which is 11 pi by 6. So those are the solutions on 0 to 2 pi. They also want general solutions, and the quick way to write those is after each of these items you put plus 2n pi. And technically that is all it takes to get you the general solutions. Now, pi by 6 and 7 pi by 6, these solutions can be compacted down, and the top left and bottom right solutions can also be compacted down. So if you want to try that, the fact that these go 1 and 7 and 13 and 19, they're always differing by 180 degrees or by pi, means you can write pi by 6 plus n pi, and that'll take care of the top right and bottom left solutions. The fact that these solutions in the top left and bottom right also differ by just pi means you can write 5 pi by 6 plus n pi if you want a very neat and finished solution. But generally, you'll get all the points even if you just get these 4 values and put plus 2n pi. Over to this next one. Tan squared x plus tan x. This is like t squared plus t. There's a common factor which you take out first. And that leaves us with tan x plus 1 equals 0. And that gives us 2 first-degree equations. When we break it up, we get either tan x equals 0, or we get tan x plus 1 equals 0, which tells us tan x is -1. Here I kind of need 2 sets of axes because we don't have the same number in both of these cases. If tan is 0, which means y over x is 0, we could be in 2 different places. We could be over here on the right side at 0 degrees, or at 0 radians, or we could be over here on the left at pi radians. Those are both places where there is no rise. The line is totally flat, and we get tan equals 0. So we get the solution 0 and pi and 2 pi, and then we get 3 pi, 4 pi, 5 pi, and so on forever. When tan is -1, or if you want to write it -1/1, that happens in the two quadrants where tangent is negative, meaning it can happen in the top left, or it can happen in the bottom right. Watch your signs here, right? This is to the left, so it's negative. Up is positive. For this triangle, to the right is positive, and down is negative. You'll recognize these as, I started to write 45 degrees, but what we want actually is pi by 4 radians. And this is pi by 4 radians. So our actual solutions are 3 pi by 4 in the top left. There it is. And down here is 7 pi by 4 in the bottom right quadrant. Those are the two solutions from 0 to 2 pi. If you want the general solution, what do you put here? Don't say 2n pi. For sine and cosine, it's 2n pi, but the period for the tangent function is actually just pi. So plus n pi is actually all it takes to get you the general solutions here. Now, so we have the first part of our solution is 3 pi by 4 plus n pi. But look what happens. If you do 3 pi by 4 plus just a single pi, you get 3 pi by 4 plus 4 pi by 4, which gives you 7 pi by 4. You get this solution for free. You actually don't have to put 7 pi by 4 plus n pi because this expression takes care of it already. So while the 7 pi 4 is correct, you don't need to list it separately. Just saying 3 pi by 4 plus n pi will get you this solution and this one and all the other ones besides. So, lucky.